In the previous two videos we have seen the chapter 4 threads. Okay, so that is the first chapter belongs to module 2, and in this module 2 the another chapter is process scheduling. So here how the processes are scheduled among the multiple processes, which process should come first, how much time it has to execute, at what time it has to exit, either from a running state to the terminate or running state to the waiting state, etc. Okay, so this chapter consists of five concepts, five subheadings: basic concepts, scheduling criteria, scheduling algorithm, multiprocessor scheduling, and the last one is thread scheduling. Among the five, so there is one very important concept called scheduling algorithms, where we will get 4 to 5 different sub concepts. So among those algorithms or the methods or problems, definitely one problem will be there in the examination for about 6 to 8 marks minimum. So sometimes even some other problem they may add on for making it up to 10 to 12 marks problems. Okay, so please concentrate more on this chapter. So let's start with the first concept, that's the basic concepts of CPU scheduling, also called as process scheduling. Okay, so now here first let's see the diagram. So some letters are in bold, something is in a blue color, white, and again some different color. Okay, now one sure thing is the bold letters. Okay, so now you can see there are some flower brackets which indicate a time duration. Okay, so start of a flower bracket means that activity has started, end of the flower bracket means that activity is ended. Okay, so now here you see there is something keyword which I read out, that load, store, add, store, read from the file. So this is what this corresponds to CPU burst. Okay, this corresponds to burst, BURST. So next we have blue color, wait for input output. So again we have something store, increment, index, write to the file, which is CPU burst. Wait for input output, which is IO burst. So again something in the bold, CPU burst, IO burst. Now, so first thing, burst means smallest amount of the time, which is measured. So I could say CPU time, IO time, CPU time, input output time, CPU time, input output time. Okay, now coming back to this part. Okay, now one important point here what we could see is analyze this flow as ATM machine. So what happens if I enter ATM center or the point? So I could insert the card. Okay, once I insert the card, some activities will take place in the machine which we are not controlling, but they are executing, like whether card is valid or not, card is chip enabled or non-chip enabled. So these decisions are done. So who is going to do that? It is done by ATM machine CPU. So it will give us a welcome message. So and we can see the welcome message. Next is type your PIN number, or type your PIN number. So it is waiting for my input, means whatever I wanted to give, for that it is waiting. So now once it waits, so I will give them PIN number called 1234 or something. So the time, how much I took to read out the screen, something on the monitor, to give the this one PIN number, then pressing the enter button. Okay, so this time is called as input output time. Okay, so once I give my PIN number, then it again CPU work. What it will do, it will check whether the PIN number is correct or not. So at this time, when CPU is checking PIN number correct or not, I have to wait. I cannot give any of the data. Okay, maybe it may take 1 second or 2 seconds, but we have to wait. So now that ATM center, this one CPU has verified I have entered a correct PIN number. So then what it will show me is menu, whether you want to withdrawal, you want a pin number, mini statement, etc. So what I do, I will read menus given on the computer display, that ATM machine display. So here I am reading. So computer is not doing any work because it has shown the menu. Unless I select anything from the menu, computer cannot do any of the activity. So computer is waiting for my signal. So what I select withdrawal. Okay, so if I select a withdrawal, what computer will do is it will ask me to give the valid amount. I cannot give 25.5 or 80 rupees, etc. So I have to give like 2000, 5000, etc. Something I have given. So next, once I give the number as well as enter button, it will checks. Now CPU work starts. So it has to check whether the amount is valid or not. Is amount present in the ATM machine or not? Then the same amount is present in my account or not. So who is doing that? CPU will do. Once it is done, once everything is done successfully, then it will give me the money. Okay, after verification and all the steps, it will give me the cash. So now it is the machine is waiting so that I can collect cash. Okay, so it will keep the currency notes on the dispenser. So I have to pull it out the caches, pull out the caches and remove my card from the ATM machine. So here there are every step there is one alternative activity. CPU did the work, then input output I did the work, again CPU did the work based upon what I have given, then after that CPU calculation, again it asked me some question. I have took a time and given values. So on what values I have given, it calculated something. Okay, then it gave me something again. Okay, some other like a currency or a printout, etc. So again I took it out and continue. So here what we will get from this diagram is computer always may not collect all the data at once. It is an interactive system. So first it will check something, it will expect me to give the data on that particular time. So then based upon the collected data, it will calculate, it will decide whether he should go for a cash withdrawal or a mini statement or printing the pin number change, etc. Some works. So finally what happens, every time either CPU will be busy or user will be busy alternatively. Okay, now whenever computer is busy, how much time computer is busy, that is called as CPU burst cycle. I repeat again, if computer is busy, okay, CPU execution time or CPU burst time. If user is busy, then it is called as IO burst time. I repeat again, CPU burst time or also called as CPU burst cycles. How much time the CPU is busy. IO burst time, how much time input output has been taken or the time taken to collect the data or to give the result. So these are called as CPU burst and IO burst. Now comes CPU scheduler. Hope you all remember two type of schedulers, long-term schedulers and short-term schedulers. So here we are discussing about short-term schedulers. Okay, short-term schedulers generally will do in terms of microseconds or milliseconds, whereas long-term schedulers may do in terms of seconds or minutes or hours. Okay, so now the question, so what all the things we will come to know by CPU scheduler. Okay, so what the terminologies are required to understand the CPU scheduler and what are the subsections. First thing, CPU scheduler works based on short time or short term scheduler. So it selects one activity from the menu and give its resources, whatever the resources it require, and make it to execute to generate the result. Once the result is generated, then it will take back that process from the execution state. So hope you all remember some states of a process: created, ready, running, terminated. So meanwhile here interrupted and waiting state. So these all are some extra states what we remember. Okay, to make sure a process is execution, so process should enter running state. I repeat, running state. If process is not entered running state, it is not at executing any of the activity. Okay, make it very clear. So to make process to enter a running state, operating system should do, or this scheduler should do, give whatever he has requested. I mean process has requested. If process has requested for CPU, give the CPU cycles. If process has requested for input output, give the dedicated input output device for that process. Only then we can expect the output from best scheduling from scheduler. Also a particular or group of processes will execute and they generate the result for the user. Okay, now 2 to 3 points with respect to scheduling, how it decides. Okay, whenever there is a decision, what all things will take place. Processes will switch from, as I said, running, okay, running to wait state. When this case happen is when the requested resources are not possible to provide on time. Okay, so very simple way, the counter is we all are standing in the counter to pay some electricity bill. So 3 members are ahead of me, and it's my turn. Okay, next is my turn. So suddenly what happens is the representative or that counter person has got one call from his higher authority. What he will do, he will stop collecting the bill from the customers who is standing there, and he will attend the call. So what happens during his call, we all are in the waiting state. Okay, so that person who is exactly nearby the counter, he also is in the waiting state. So what he will until what step or until what time he is in the waiting state is until that person stops communication with the higher authority. So then once it is he comes back to the work, so we can give our money and get the bill paid. So next, from ready to running state, I mentioned this transition in our previous chapter. Ready, what is the difference between waiting and ready? Waiting state means resources are not yet allocated, whereas ready means resources are ready and process is also ready, everything is ready, but execution is not yet started. So now the condition, running to ready, when it is possible, running to ready. Okay, so presently process is in the running state. Okay, so some resource whatever it is required, it was a busy, just now it has been allocated, and it no need to wait. No, this has a more priority, so no need to wait, it is about to start execution. So that is a transition from running to ready state. One more transition from waiting state to ready state. So what you mean by waiting state? Always this is compulsory. Waiting state means resources are not allocated. Ready state means resources are allocated but execution is not yet started. Okay, so the last state or the last scheduler is the termination. So when termination is there, termination, there are 2 types of terminations which I mentioned. Successful termination after completion and abort of the process because of incomplete termination. So when it is aborted or incomplete termination is either resources are not at all available, or in the given amount of a time process is not able to finish his work. Okay, so these are the 2 things for abort. One best way of termination is successful completion of the execution. Okay. So the CPU scheduler has 2 type of scheduling methods. One is preemptive and another one is non-preemptive. Okay, so preemptive and non-preemptive, actually how both will work you are going to get in the future problems. As of now, let's understand that preemptive means if something is working, okay, some process is under execution, another process with a high priority arrives. Okay, should the present executable instruction stop and give the CPU for the higher priority process or not? Based upon that we will decide whether it is a preemptive or non-preemptive process. Okay, so scheduling, when it is operating system should decide whether the preemptive is more important or not. Preemptive means cooperative or etc. So here when there is a shared data, we should think about preemptive. So what happens with respect to shared data? Simple way, there are 100 or something 140 students and we have 70 operating system books. In that case, what happens? Who will come first? Okay, so that person or those student will get a textbook. Okay, so mean if there is a shared data, there will be some algorithm for managing the resources. Okay, so next, so suddenly what happens, there are all the 70 books are available with the student. Suddenly some high priority person like okay, someone will come and ask. So what that the library person can do is, he will check out the list of operating system who took the book very long days back, call him, collect it from him and give it to the other person. Okay, like that. It depends upon different type of algorithm. All the algorithms we have to discuss, so don't worry, it depends upon the different situations also. Okay, so what scheduler will do? Scheduler will make a timetable for short term execution of a process. Okay, so it will make a switching of a process from running to waiting, running to ready, waiting to ready, and finally termination, whether it is allowed to terminate or not allowed to terminate. Okay, so now there comes the word dispatcher, who sends out. The dispatcher meaning is who sends out. Okay, so now what is concept of sending out is, say there are 5 processes, assumption there are 5 processes. Among the 5, something I have to select, one I have to select, so I have to send him for execution. See, whenever I am sending him out for execution, that sending out work is dispatcher. Okay, how it is done? See, all the activities, whatever given, all the activities or the processes given by the user, they are stored in job queue. I hope you remember the word job queue. So job queue means where we are going to store works. So among the job queue or the job order, I mean in the job queue there will be some job order. So those, according to that order or that particular order, we need to send them out one by one for the execution. Okay, so that is the word we are using for dispatcher. During which all time dispatcher is important? Whenever we are exchanging 2 or more processes among themselves for the execution, we have to think about a dispatcher. Okay, we are switching from user mode to kernel mode and vice versa, then also we have to think about a dispatcher. Okay, so if suddenly assume a case, computer is working in a user mode, suddenly it want to change into the kernel mode. Okay, if we don't inform users that the computer is going to shift into kernel mode, so what they will do, they keep typing the data or giving the input, but computer without information, if it enters from user to kernel, even though user is entering or typing, it is not going to get stored. So to avoid such a data loss, possible data loss, computer should inform whenever it is switching mode from kernel to user or user to kernel. So there is a word called dispatch latency. So during sending out, is there any delay happening? If delay happening, what is the reason and what it made the delay? So try to identify or rectify that delay so that the product will come out on time and there won't be any of delays. Okay, fine. So after the basic concepts, let's go for some of the technical scheduling criteria definitions here. So this is the concept where we are scheduling, basic scheduling criteria. Okay, so we have finished the concepts in that what you mean by CPU burst, what you mean by IO burst, and what are the activities of a CPU scheduler and how the dispatcher works, that we have seen. So now comes 5 important, very important definitions. You can get it either as a Viva questions, or you can expect these as the important definitions which are required for the next step called scheduling algorithms. Okay, so the first point, CPU utilization. So it's a total time used by a process, okay, to finish its execution. Say for example, I have one program for C equal to A plus B. So it took 10 milliseconds for execution. Okay, you after the here a lot of concepts are there, whether A, B values are already known or they are collected by the user at the execution time. Okay, so whether C value, only C we have to store, should we store the C using some pointer? So like this, so many parameters are there, but in generally we call the total time taken by a process to finish its execution is called as a CPU utilization. Okay, now comes whether CPU utilization includes, let me take the reality diagram here, CPU burst. Okay, is CPU burst alone called as a CPU utilization? Yes. Okay, but not all the time there will be only one CPU burst. There will be many CPU burst. So what we have to do is, it's a starting time to end time. We have to calculate a total time 1, time 2, time 3. 3 times CPU burst summation if you do, that is called as CPU utilization. Okay, simple way like this. See what is the in a day, how many hours a student will sit in the class once he enter the college. So let's take our timetable 8:30 to 3:30. In this 8:30 to 9:15 one session is there, so 45 minutes. So there is a gap of 1 or 2 minutes, previous session completion, next class starting, so exclude it. So about 43 minutes each side, or 40 minutes one session in the first 2 sessions in the morning. Then comes 2 hours of theory classes. Okay, so even though it is a theory class of 2 hours, we are getting some 5 minutes gap between each, or 10 minutes gap sometimes. Okay, depending upon the network. So then what happens, then we'll get a lunch break. Okay, lunch break is not called as the class, the teaching hours, so we have to exclude it. So again in the afternoon, some day we have full classes, some day we have a lab for 2 to 3:30, some other day we don't have any of the classes from morning to the evening, like Saturday and Sunday. So meaning of time of learning is somewhere around 5 hours or 6 hours. In the same way, how we excluded lunch break, then tea break, etc. Here also in CPU utilization time, total time, how much total time the process is in the execution state, excluding wait state and ready state. So next, throughput, how many number of processes getting completed in per unit time. Generally in 1 second, how many processes are completed. So for us, we look like if 1 or 2 process finishes, we will be very happy, but computer will be doing in terms of MIPS. I hope you all remember the unit MIPS. Let me type here, million instructions per second. So that means what, 1 lakh or some number of lakhs, like 2 lakh, 3 lakh, 10 lakh works the computer is able to do in 1 second of a time. So that is called as throughput. Now comes a turnaround time. Please make a difference. CPU time is not the same as turnaround time. Turnaround time includes CPU time plus waiting time. Okay, coming back to this diagram, only CPU burst, if I add, it become CPU utilization. Only waiting time sum, if I do, it become waiting time. Okay, IO burst, if I add IO burst 1, IO burst 2, IO burst 3, it becomes a waiting time. If I add CPU burst 1, CPU burst 2, CPU burst 3, it becomes a CPU utilization time. If I add CPU burst 1 plus IO burst 1 plus CPU burst 2 plus IO burst 2 plus CPU burst 3 plus IO burst 3, the total summation is called as turnaround time. Okay, so let me give you the idea. Turnaround time, okay, TAT equal to, okay, waiting time plus CPU time. Okay, so this is what the effect, definition. So next is what do you mean by waiting time? Here waiting time is called as the total time in which user took time to give the data or user took time to collect the result. So that is called as waiting time. So generally in today's world, waiting time is very higher than the CPU time. If you go for ATM machine, okay, so how much time computer will give us to show the menu and how much time I will take to select a menu, one option from the menu. So computer will take a fraction of second, whereas I will take 1 to 2 seconds of a time to select, because I will be using mobile or I will be holding a bike key or etc. I need to swap the keys and swap the mobile, then I have to enter it, okay, or select. Simple way. One more way, computer will as soon as I hit a pin number, computer processes in a fraction of a second, but I will take at least 4 seconds of a time to enter my pin number. So that is what meaning here. Okay, so always waiting time will be more because user is doing work. CPU time will be less because computer is doing a work. Computer can do work 1 lakh work or 2 lakh work per second, whereas a human being can do 1 work per second. Okay, next is what? Response time. It's a time, how much time it took to respond for any of the signal occurred. So respond. So you have given a ATM pin number, so it has to respond, yes, pin number is valid or not valid. Don't worry about the valid or not, but how much time it took to respond, that is a response time. So now here let me give the equation forms. Okay, so wait time, first I will give CPU time. CPU time is equal to CPU burst. Okay, so let me give some summation of, so I can give it, you will also identify summation of all the CPU burst starting from 1 up to the last burst of n. That's a CPU time. So what about waiting time? Let me give here. The waiting time is equal to summation of input or output time for the first, I don't write a time, I will write a burst because I took that reference, burst up to what? Input bar output of the burst nth. So that's how to give the representation. So next is what? Turn around time is equal to CPU time plus waiting time. Hence, what is the total definition of turnaround time? It's a summation of all CPU time plus summation of all the waiting time of input output. That will give us turnaround time. So what do you mean by response time? It is a minimum time took by the process to give first ever response. So for response, how much time it has took, that is called as the response time. Now here, do we need always calculate a turnaround time? Yes. So our target is to calculate turnaround time because turnaround time is important with respect to CPU time as well as waiting time. Okay. Next, so scheduling algorithm optimization criteria. So what we should optimize, what are the things we should optimize, what are the things we should increase? Okay, so what we have to do is try to maximize CPU utilization. Okay, so we have to try to make a CPU utilization more, try to make a maximum throughput. Okay, so try to make minimum turnaround time, same for the other. Let me give you the analysis: minimum waiting time and minimum amount of response time. So one by one let's discuss. What do you mean by maximum maximize the CPU utilization? So what happens if you don't do that? We have to think. Okay, so here let me type like maximize, and here I will type it as minimize. Okay, so why we should maximize the CPU utilization? So if we don't do CPU utilization to the best level of upper or maximize, so here meaning is you have one machine, okay, which can do which can print 10 papers per minute. Let's assume 10 papers per minute, and I am giving him 3 papers per minute. So why I'm doing, even though his capacity is more, I am giving him less work. So I have to give him more or maximize its CPU utilization. I have to think in a such a way that can I enhance from 10 pages to 12 pages. So because my target is what, within less time I have to get a more printouts. So in that case, try to identify the drawbacks or where there is a time consuming that activity, try to reduce it so that I can get a more printouts at per unit amount of a time. So because why we have CPU is to make work instead of me and keep me relaxed or free. So if computer is ready to do the work, and my intention is also to get work done by the computer, and I am not ready to maximize the CPU utilization, means I am not utilizing a resource properly. So to avoid that, we have to think about increasing the CPU utilization. Also we have to increase the throughput. Why throughput? Because the throughput definition is what? Number of processes complete. Number of process completes. So what is advantage of having more number of processes completion in a shortest time? Of course we will get a main result in soon, I mean lesser time. If we don't maintain a good throughput, what will be the problem? So first process will make a delay, some 10th process will make a delay, 25th process will make a delay, ultimately 100th process will also be make a delay. So totally we will end up with a very late execution. So try to maximize the throughput. So why we should reduce remaining all? Why we should increase the first two? First two are, by increasing first two we can increase the efficiency, okay, whereas in the last three, to increase efficiency we have to reduce these three. Why these three are to be reduced is because they are 3 states or 3 points which will considers or which will make our efficiency of a system lesser by increase in the waiting time, increase in the response time. If I have a computer and if I have a ATM machine, if I put a card now, I expecting to give the next window after 2-3 seconds at least. So if it takes 1 hour of a time, so what is the response time there? Response time, one side we have 2 seconds, another is 10 minutes. So which ATM machine is faster? If the response of a machine, one is 2 seconds and another one is 10 minutes. So definitely I will prefer this 2 seconds and I will cancel this usage of ATM machine whose response is very slow. So next, not only response, once I hit the money, how much I wanted to withdraw, it will take one machine will take 2 seconds of a time, another machine will take 10 minutes for confirmation whether that much amount is present or not. So I need to wait there. So totally it is taking too much time for me because of more waiting time. So if I reduce this, definitely it is going to be friendly for the user and he will also try to use the machine because it has less amount of waiting time. Okay, so last point, why we have to minimize the turnaround time? Why not we have to think about increasing it, even though turnaround time is consisting of CPU utilization. So please remember, CPU utilization is opposite to the waiting time. If CPU utilization is more, waiting time will be less. If CPU utilization is less, generally waiting time will become more. So what we have to do is we should come up with a situation where turnaround time is a combination of CPU time plus waiting time, both. Here try to reduce this waiting time and also try to increase this CPU time, so 100% total system efficiency will increase like anything. Okay, so you can see here very simple way. think like this: you are standing in some queue for getting a ticket or etc. Okay, ticket for a movie, which is probably a dream in this pandemic situation. Okay, anyway, let's assumption. So the counter person who is issuing a ticket, he is little slower. He is little slower. So what happens? I need to wait for a long time. I need to wait for long time because he is a slower. What I will do is I will replace that person with a new person who is a faster. So if he is a faster, he can issue the ticket very fast. So what happens? Every person waiting time is what? Waiting time is reduced. So they will be happy with the system. But what about a CPU utilization? So if he is issuing a ticket fast, he will give input to his computer, and computer will give printout of a seat number very fast. So thereby we can expect that CPU utilization has become more or increased. Okay, now comes, let's take a first algorithm which used for scheduling of the processes. So very simple task. Okay, so there will be set of processes, please remember this, set of processes and their burst time. There is no differentiation between, okay, please listen carefully, there is no differentiation between whether it is a CPU burst or a IO burst. So if it is a burst is given, we can think either it as a CPU burst or it as a IO burst or mixture of a IO as well as CPU burst. Okay, so there are three processes, process 1, 2 and 3. First process will take a 24 units of a time, second process will take a 3 seconds, and third process will take another 3 seconds. What is the algorithm name here? We have algorithm name first come first serve. So this is FCFS, first come first serve. So now in the statement it will be given the above processes arrive, please remember this word arrive, they arrive in following order. What is the order? P1 first, P2 next, P3 last. Okay, so make the Gantt chart, G-A-N-T-T, Gantt chart. Okay, this is called as Gantt chart. Is it right now? Okay, fine. So how to do the Gantt chart? It's a rectangular horizontal box, in which inside the box we write a process, outside the box left of that process for us means if I write P1, my left I will write it as a starting time, my right I write it as end time, my right I will finish it as end time. Okay,